Welcome back. In continuation to the last lecture where we discussed the syntax of modal logic, we introduced various kinds of translations, etc. How a sentence like "it is possible that P can be or it can be the case, it might be the case," etc. Those sentences which involves these modal operators, how it can be translated appropriately into the language of modal logic, etc. is the one which we have discussed in the last class. And we have also seen that any two given modal logical formulas, well formed formulas, they do not have the same syntactical structure. If you draw the tree diagram for a given formula, they always look different. If they are same, they are considered to be identical to each other. So, in continuation to what we have seen in the last class, there is a convention, just like in the case of propositional logic, we follow the same convention even in the case of modal logic as well. So, basically we are discussing normal modal logic, which is considered to be an extension of classical logic with two operators. It is possible that P and it is necessary that P is the case. So, now for example, if you are given a formula which does not have any parentheses, so then again in the case of classical logic, we followed this convention that first you give preference to negation, and then followed by that conjunction, disjunction, implication, and by implication is the one which we this is the one that we have used. And the preference, the least preference that you have given, that is by implication, will serve as the major connective in your given formula in the case of propositional logic. In the same way, in the case of modal logics, the first preference will be given to negation, followed by that necessity and possibility, which bind closely, followed by other things like conjunction, or, and then followed by that we have implication and if and only. So, it is like this. So, the convention that you follow is like this. So, this is in the case of classical logic, and this is the case for modal logic. So, first preference will be given to negation, followed by that conjunction, disjunction, implication, and by implication. So, in this case we have negation, necessity, possibility, and of course all the other things, and or implies if and only if. For example, if you have a formula like this, necessity of P, Q, and R. So, we do not have any punctuation which is there in this particular kind of thing. So, this formula can be read in two different ways, just as in the case of classical logic. It can be read as necessity of P implies Q, or the other way around is that necessity of P implies Q or R. So, these two formulas have different syntactic structure. So, now how to put parentheses for this one, suppose if it is not given to us. So, now we follow the convention that is listed on the right hand side of the board. So, the first preference should be given to the necessity operator, necessity followed by this thing, and then we have only these connectives which are linked with the propositional logic, implication, and R. So, in our preference, first preference should be given to R in this case also. So, you put bracket here like this, and then you close it like this. So, now this sentence needs to be read like this: necessity of P implies Q or R. So, in that way, if your parenthesis is not given, we follow some kind of convention, and using that convention you will come to read the formulas in a better way. So, here is there are some other examples which are there here. Necessity of possibility of Q and not R implies necessity of P. If you use this parsing kind of tree, then how you write it is in this way. First you take care of the negation and modal operators, etc., and then followed by that you take care of all the logical connectives exactly in the same order as in the case of propositional logic. Now, what do you mean by saying that something modal logics are considered to be normal modal logic? A normal modal logic by definition has these properties. L should contain all the tautologies. All the tautologies of propositional logics are intact. We are not disturbing them because modal logic is considered to be an extension of classical logic, classical propositional logic. If you extend the classical propositional logic, we have normal propositional logic, normal modal propositional logic. So, L contains the instances of a distribution axiom, which is a characteristic axiom for a particular logical system, that is K. It is necessary that phi implies phi implies it is necessary that phi implies it is necessary that psi, and L should contain all the instances of the instances scheme such as duals. For example, if necessity of phi can be defined in terms of possibility, in this sense necessity of phi if and only if it is impossible that not phi is the case. In the same way, phi can be defined as it is not necessary that not phi, and a given logical system L has to be closed under uniform substitution, and it has to be closed under even modus ponens also. Modus ponens is it is necessary that P implies Q, and then we have necessity of P, and then we have necessity of Q. So, this is modus ponens rule, and then we also have another rule which states like this: if alpha is already a theorem or a valid formula, then all the valid formulas are obviously have to be necessarily true. Then we have this thing, necessity of alpha from alpha. So, this rule of necessitation should not be used loosely, in a sense that if suppose alpha is said to be a contingent kind of sentence, or for example, if you say that alpha stands for this chalk piece is yellow in color, that does not imply that this is necessarily, it is necessarily true that it is this chalk piece is in yellow color. It applies to only theorems which are already proved ones, or they are considered to be valid formulas. All the tautologies have to be necessarily true. So, other thing is that L is closed under rule of necessitation. That is what we have been discussing here. If any formula we have alpha, then the necessity of alpha should also be it can also be inferred from that thing, that alpha is the thing. So, in the case of non-normal modal logics in particular, they are the worlds, it consists of worlds, possible worlds, where the truth conditions of modal operators are different. Whereas in the case of normal modal logic, suppose if necessity of A is true, then obviously possibility of A is going to be true everywhere. But in the case of non-normal modal logical systems, they behave in a slightly different way. The necessity operator is going to may be false, but the possibility operator, it is possible that A in a given world W can be true. So, that means in a non-normal worlds, this is what Lewis is talking about, particularly when he has come up with 5 logical systems S1 to S5. He is of the view that first 2 systems S1 to S3 in fact, they capture strict implication in a much more better way than the other kinds of systems that he has come up with, that they are S4 and S5. So, in a non-normal world, A is considered to be false no matter what A is. So, even this P or not P, which is considered to be so called tautology, and even P plus P are also going to be false at those in such kind of worlds. So, this means that the rule of necessitation cannot be universally applied in non-normal modal logics. So, that is the main difference between normal modal logical systems and non-normal modal logical systems. In our course, we will be focusing our attention on normal modal logical system, where the necessity operator behaves in a uniform manner, or any logics that follows law of distribution axiom, that is K, and which is closed under modus ponens, can be called as normal modal logics. So, what is considered to be the minimal modal logic under normal modal propositional logic? So, it is due to the logician Saul Kripke. Every logical system is named after some logician or other. It seems to be the case that this logic, the name was due to this logician Saul Kripke. So, its axioms includes all the tautologies of propositional logic which are intact, plus we have distribution axiom, necessity of P implies Q implies necessity of P plus necessity of Q, and we have uniform substitution rules. For example, if you have necessity of P implies Q, for example, this is what we have, necessity of P implies necessity of Q. Now, if you uniformly substitute, let us say not P for P. So, this means wherever P occurs, you substitute it with not P. So, now this formula becomes this thing, not P implies Q implies it is necessary that not P implies it is necessary that Q. So, this is a uniform substitution of this one. The only thing is that we have replaced P with not P uniformly in this formula. Any given formula, if you substitute for any propositional variable, you substitute any other kind of variable, then obviously it is considered to be said to be uniform substitution. And we have a necessitation rule which we have already discussed, and we have modus ponens rule. This is K. K is a system that includes all these things. In the next class, we will be talking more about the axiomatic systems, and we will be seeing some of the theorems within the given model logical systems, and we are also going to see how these theorems can be proved by using these axioms, uniform substitution and necessitation and modus ponens rules. Suppose if you say alpha is a theorem in K, if and only if there is a sequence of formulas of which alpha is considered to be the last such kind of step in the sequence. I mean, the last step is considered to be the theorem, last step of your proof is considered to be a theorem. So, that final step has to be either a theorem, or it has to be an axiom, or else it is derived from derived by means of one of the rules from formulas appearing higher up in the sequence. So, we have something like P and Q. So, the idea here is that your journey starts from the truth and your journey also ends with the truth. The last step of your theorem last step of your proof is considered to be a theorem, and every step that we are subsequently taking into consideration from P all the way down to Q are either theorems, or you arrived at those steps by means of uniform substitution, or you applied some kind of rules like modus ponens, etc. So, let us consider a little bit of translation concerning normal propositional modal logic. These are like this. All the things, translations which are there in the propositional logic are like this. Not P is translated as not P. Both P and Q are translated as P and Q. Either P or Q, P or Q. Sometimes it can be used in exclusive sense and inclusive sense. Unless until I state it explicitly, it is used in the inclusive sense. That is P or Q, or it can be the case that both of them. Coffee or tea, but given a chance I will take both the things, coffee as well as tea also. But if you say exclusive or one excludes the other possibility. Fruit salad or ice cream. If you take fruit salad, you are not supposed to take ice cream, and if you take ice cream, you are not supposed to take a fruit salad. That is exclusive or. Not both of them you will be consuming. So, possibility of P is simply translated as diamond P, necessity of P, box P, and P in spite of Q. Instead it is written in terms of P and Q, P only if Q, and P is sufficient condition for Q, or Q is necessary for P. All these things are translated as just P implies Q. If you say that P is a necessary condition for Q, it is translated into Q implies P. We need to know a little bit about the scope of the modal operator. So, we have this problem right from the antiquity as to whether the modality applies to the whole conditional or part of the conditional. So, in general what we are trying to state is that modality applies to the whole conditional. its scope is big rather than it's having narrow scope. So in this case necessity of P implies P and Q implies R. In this case the necessity operator operates on the whole conditional. So that is P implies P and Q implies R, that is operated by this necessity operator. Even in the second case it is like this, necessity of P and Q implies P and Q. So this necessity applies to P and Q. Now consider this interesting example, third example. If Socrates is human, then he must be mortal. So usually we translate it like this. So there are two translations which are possible for this second thing. If Socrates is human, then he must be mortal, assuming that H stands for human and then M stands for mortal. You can write like this, mx or something like this, but we skip it for convenience. So the second translation is this one, necessity of H implies M. So in most of the cases what we are trying to state is that this is the correct translation over the other one. Suppose if you are in a confusion that you have two such kind of translations, the idea here is that if you go with simply literal translation, this seems to be the appropriate kind of translation. If Socrates is human, he must be mortal. Here this says that if Socrates is human, then he has to be mortal. So this necessity operator operates over the whole conditional. So in most of the cases this is considered to be the correct translation rather than this one. This is having narrow scope, this has a wider scope. In the same way, fourth example, of necessity, if Socrates is human, then he is mortal. It's not moral, mortal. So the modalities operate over the whole conditional rather than the part of the conditional. So now there are some other kinds of things which we will be coming across while translating the English language sentences appropriately into the language of modal logic. So as we have seen in the case of propositional logic, there are three kinds of sentences. On the one hand we have tautologies, those sentences which are always considered to be true, and contradictions, those sentences which are always false. And there are sentences which are sometimes true, sometimes false. It is raining outside, it is true, sometimes false. Today it is true, tomorrow it may be false. So now how to translate these sentences appropriately into the language of modal logic. P is necessary is simply translated as necessity of P, box P. P is contradictory, means not P has to be necessary, and P is possible is simply translated as diamond P. Now P is contingent, like anything which is related to things which are related to future. I shall be in my native place on so and so date. So that is a future contingent sentence. So that is translated as possibility of P. When you say possibility of P, it is also possible that it is not P also. So when you booked your ticket, and then obviously you will be thinking, you will be hoping that you will be in your native place, but some other thing might happen, some other commitment, because of some other commitment you may not be in your native place, or the train is cancelled or some other thing happens, then you will not be in your native place. That means if you say that something is possible that P, there will always be the case that there is also something which is not P also. So if you do not make this distinction of possibility of P, necessity of P and P, then in classical logic this possibility of P and possibility of not P is simply viewed as this, because it does not make any distinction between possibility, necessity and something which is considered to be actual. So there is no such kind of difference. So this is interpreted as this one. So this is considered to be a contradiction, but in modal logic this need not have to be contradiction. It is possible that P, and of course it is also possible that not P is also the case. So P is not contingent. Not contingent means you need to put one negation here. So something which is contingent is this one, something which is not contingent is this one, necessity of P, necessity of not P. Of course, you know, if you want to simplify it a little bit, then it will become negation of possibility of P, negation of conjunction is R, and this will become not P is P. So again it further simplifies to this thing, necessity of not P or necessity of not P. The negation of this one second, negation of this and negation of possibility of not P. Sorry, this is not P. So not P is as it is. So this is a negation of not P. So this becomes this one, negation of necessity of P. So when a sentence is said to be analytic, then either P has to be necessary or not P has to be necessary. So P is analytic is translated in this way, and P is consistent with Q. In logic we use the phrase consistency, but in the case of natural sciences etc., we use a similar kind of word, that is compatibility. So P is consistent to Q means P and Q has to be there and it has to be possible. So it is possible that P and Q stands for P is consistent with Q. P is compatible with Q, just you want to say that this is different from the logical consistency. We have used a different symbol here, so that is P is O Q. It is same as it is possible that P and Q, and P is incompatible with Q means it is not possible that P and Q is the case. So usually compatibility etc., all these things we use it with respect to physical necessity. So when we discuss more about possible worlds, then we are going to see things which are true in all possible worlds mean logical necessity or metaphysical necessity, things which are true in only some necessity with respect to laws etc., nomic necessity or some other kinds of necessity. We have different kinds of necessity. So here are some of the examples. This goes like this: necessarily if snow is white, then snow is white, snow is white, or grass is green. So now here the necessity operator operates over the whole condition. The whole condition is S implies S or Z. Now the second is I will go if I must. So this is translated as it is necessary that G implies G. Like this we translate it like this, and coming back to the fifth example, God's being merciful is inconsistent with your imperfection of being incompatible with your going to heaven. It seems to be a little bit complicated kind of sentence, but you have to break it. So first you need to read it like this: what is incompatible with going to the heaven? That is I and H, these are incompatible. I and H is incompatible means this is the formula. It is not possible that I and H. So now this one together with God's being merciful has to be consistent, inconsistent. So this together with this one, it has to be inconsistent. If it is consistent you put like this, but if it is inconsistency you put negation here. This shows that this part and this part are not consistent to each other. The sixth example is the one which we have already seen. Nothing is absolutely relative. Things are relative is it is possible that P and it is not. It is also possible that not P, and this is not relative. This is nothing is absolutely relative means whatever is the case, possibility of P and possibility of not P need not have to be necessary. So while translating etc., we need to take care of the scope of the modal operator. So now based on we just spoke about minimal modal logic, and till 1960s the attempt was this, that modal logicians were trying to come up with various kinds of logical systems, and they are named after one logician or another. For example, we have D. D states that it is necessary that phi implies that it is possible that phi. The same kind of formula which you are seeing it here, it is necessary that phi implies that it is actually true, that may not apply in D. For example, if you say that you ought to follow the traffic rules implies that you actually follow the traffic rules. It may not be the case. You can come up with a counter example where you ought to follow the traffic rules, but you sometimes in some cases you might break that particular kind of thing. When in the case of emergency, you are in an ambulance or something like that, you will be breaking the rules. So, modal logicians were trying to come up with various logical systems which suits some of the interesting things. Till the development of Kripke semantics, modal logicians were constantly trying to prove theorems within these logical systems, and they have come up with characteristic axioms, and these characteristic axioms are like this. In the next class we will be dealing in a we will be dealing in these things in a systematic manner. Thank you.